Welcome to Center of Math's Advanced Knowledge Problem of the Week. For this week's problem, we're given a subgroup H of a group G. We're given N is the normalizer of H, and we want to prove that the number of different conjugates of H is the order of G divided by the order of N. So first, N is a subgroup. N is a subgroup of G such that the conjugate of H, HA, just gives us back H. So H is a normal subgroup of N. And so the first thing we want to establish here First thing we're going to want to establish is if the conjugate H, HA, A minus 1, this subgroup is equal to the other group B, H, B minus 1, if these two conjugates are equal to each other, then A and B are in the same coset of the vector group G quotient N. And so to prove this, first let's assume the left side is true. So first we assume the conjugate of H with respect to A is equal to conjugate of H with B. And so then we multiply by the inverse of B on the left side and B on the right side. This becomes inverse B A inverse times B equals H. Note A inverse times B is just inverse of B times A, the inverse of that. So inverse B A H, inverse B A, the inverse of this whole thing gives us back H. From this we can conclude that inverse B A is in fact just part of the normalizer by the definition. And because it's part of the normalizer, we multiply inverse B A is some n member of group N. So A is equal to B times some member of this group N. And so from that we can conclude AN, the quotient group GN, AN, and BN are in the same member of that. So that's one direction. So going the other way, we assume AN and BN are both in the same coset, left coset. So B minus 1A is a member of the normalizer of H. And so from the definition, we know B minus 1A, H inverse of B minus 1A gives us back the subgroup H. And so we can multiply by B and inverse B on the left side, inverse B on the right side, and we get AH inverse A equals BH inverse B. So these conjugates are in fact equal. And so we establish what we want here, that if the conjugates are equal, then the coset, left coset of A with N is in the same left coset. It is the same left coset of B then. And so this, now our problem is almost solved. So we want to count how many different conjugate groups we have. And we know the conjugate groups are different if and only if these A and B's are in different cosets. And so each coset corresponds to one different conjugate group. And by Lagrange's theorem, we know the amount of different cosets of left cosets of N, G, is just so the number of different left cosets of N is just the magnitude of G divided by the magnitude of N. And yeah, from our previous lemma, we conclude that each different coset corresponds to a different conjugate. And so we're done. So we can conclude that this is in fact the number of different conjugates that we have. Thanks for watching. Please check out centerofmath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.